Okay. This is term 1 week 7 mechanics CA. It's 2.1 to 2.3. Make sure you do these good questions, by the way, but when they put them in the material, that means he wants you to do them. Anyway, we're gonna start with the notes. We're gonna go through the UCM equations, and then we're gonna go through the projectile motion equations, but we're gonna go through them one by one, and we're gonna derive them, so like you can kind of understand what's happening. أول شي the vector part is really easy والله. You just have in 3D you have an extra k vector, but you don't ask about it in the quiz. بس يا أخي in simple terms, in two dimensional you can use projectile motion, circular motion. This is a lot of yap, but to understand first before going in, I want you to understand the delta r vector. Okay, the delta r vector is the change in position between a vector r1 and a vector r2. Okay, the change in position between them is delta r. Okay, so delta r would be r2 minus r1. In this case, it's the x's minus each other, the y's minus each other, and the z's minus each other. Z is like the third one. You know how you have x and y? Like you'd have x, y, and this would be z. This would be x, this would be y, this would be z. If you were like in 3D plane, it would be all right angles. Anyway, uh, obviously to find the magnitude of it, you just do radical x squared plus y squared, and if you have a third one, you just do plus z squared. Like you just square it and add it. The average velocity, this is a bit important, or this is important يعني. Average velocity is equal to delta r over delta t. Delta r is يعني change in position, guys, that we found here, because you know velocity is equal to displacement over time. Delta r can be thought of as displacement. You see, it's the change. You went from here to here. Okay, so v average, it has to have an I component. The vector of it obviously will have an I component, a j, and a k. Okay, so for the I component it's x2 minus x1, because we're dealing with x's. For j, you know you deal with y's, so it's y2 minus y1. For k's, it's gonna be z2 minus z1. Until now, pretty self-explanatory. When you see the questions come in, you don't even need the formula, you just know it instantly. Okay, this would be the x component of the average velocity, this is the y component of the average velocity, this is the z component of the average velocity. And then the magnitude is obviously just the magnitude divided by tau. Oh, wait, hold up. Magnitude of average velocity, magnitude of delta x over delta t. Yeah, just find the magnitude of this. Just radical and start x squared, y squared, and z squared. Okay, average speed is equal to delta L over delta T. This is very self-explanatory. Let's say, you know, it's this curve, it's like 23 meters, and it was time is, I don't know, 3 seconds, then average speed is 23 over 3. Guys, that's it, yani. Okay, here instantaneous speed and instantaneous velocity. At this point, you guys know instantaneous speed and velocity is when delta t is approaching 0, right? So when delta t approaches 0, delta, what's this? Limit, okay, average speed, sorry, I meant to write, I think, delta t, okay, because average speed is delta L over delta t. Okay, so limit, okay, and it's just equal to dl over dt, okay, because you know speed is the derivative. You derive x, you get velocity. You derive velocity, you get acceleration, right? So x is the same in this case as the length. Derive length, what you get speed, which is the same as velocity. So that's what we're saying. dl over dt, and then again same thing with velocity. Limit v as delta t approaches 0, okay, and average like limit of velocity, it's delta r over delta t, which is equal to dr over dt. Just derive r. R again can be thought of as the x displacement, okay. Velocity dr over dt has 3 components: vx, vy, vz. This you don't have to know this يعني, but يعني you derive vx, you derive x, you get vx, you derive y, you get vy, you derive vz, you get z. Then here the magnitude, here you just get this. Yeah, to find the direction, you just do shift 10 y over x, okay. Vy over Vx. And then the magnitude of speed is always just equal to the magnitude of the average velocity. Okay. Then for the acceleration, it's very easy. Delta V over delta t, and you know instantaneous acceleration is when the limit delta t approaches 0 for the average acceleration, so dv over dt. Instantaneous acceleration is the derivative of velocity with respect to time, right? Again, it has an x component, y component, and z component. So it's dv, the x component is dv over, we know acceleration is dv over dt, but the x component of it would be the dv of the x over dt, ay is dvy over dt, and then dvz over dt. Okay. Now UCM, okay? In three-dimensional motion, acceleration has two components, an, at. An is centripetal acceleration, or otherwise known as normal acceleration, okay? Normal acceleration. And at is tangential acceleration. This can be thought of in UCM. You have a circle here. On this point P, the tangent is the tangential acceleration, and the normal to it is the normal acceleration. Okay. A tangential does not equal 0 when the magnitude of the velocity or its acceleration, when the magnitude of the velocity or its direction or both changes. So A tangential depends on the magnitude of the velocity or its direction. So A tangential depends on velocity. So if velocity is changing, then A tangential changes. But in UCM, A tangential equals 0. Why? Because on this circle, as you move from here to here to here, your velocity isn't changing, only direction is changing. But the velocity, how fast you're going, doesn't change. So that means A tangential is equal to 0. Always in UCM is equal to 0. Okay? But A normal acceleration, the normal acceleration in UCM, it doesn't equal 0. It has its own formula. I'll explain it in a sec. Okay. UCM is uniform circular motion. It's the motion along the circumference of a circle with a constant speed, not velocity. Why do we say not constant velocity? Because the direction is changing, right? But the speed is constant. In UCM, velocity is not constant. Its direction isn't the same. Only the magnitude of the velocity is constant, which is the speed. So here, this is UCM. You have a point V. It's alternating. Okay, it makes an angle theta. Okay, and this is the radius. You should know A tangential is equal to 0, but A normal is not equal to 0. Okay, the first formula is the length of the arc is equal to r times theta. Okay, memorize this. I don't know what to tell, just memorize. Okay, length of the arc is equal to r times theta. If you remember from geometry, theta over 360 times 2 pi r is equal to the length of the arc. They made it equals the length. They made it a bit easier. They used the angle in radian instead of degrees. We used to use it in degrees. So if you make it into radian, you just put theta. For UCM, all angles have to be in radians. They're all in rad. Okay? And then they just multiplied by r because you made it in radian. Okay? So r theta. Very, very easy. First formula. There's a summary of all the formulas at the end, but let me continue. For a full circle, theta is equal to 2 pi rad. Okay? For a full circle, when you turn, you make a full revolution, the angle you're gonna have is 2 pi rad. Okay, that's how it is in geometry. In radians, a full circle is 2 pi. Okay, that's how it is. Okay, if one revolution is 2 pi rad, which is equal to 360 degrees, in case anything asks. Okay, A tangential is equal to 0 in this case, right? Derivative velocity divided by time. Since velocity isn't changing, this is obviously going to be 0. A normal is equal to v squared over r. Okay? Very easy. Type. هلا the formulas. The first formula you have is velocity. Okay, the linear speed is equal to r, the radius, times w. It's angular speed. Okay? Angular speed is usually given. Okay, these questions, they don't really come, but you just have to know this. V equals rw. Then, if you derive both of these on both sides, you're gonna get the acceleration, because derivative velocity is acceleration, right? Is equal to r again times alpha. Alpha is the angular acceleration now. This was angular speed, now it's angular acceleration. Okay, so it's given in rad second squared, and this is, it's very easy. Velocity is equal to rw, and then acceleration is equal to r alpha. Okay, so in linear motion, circular motion, you have differences. The distance in linear motion is s or l, right? Either s or the length in meters. But in circular motion, we're using rads, theta. How far are you traveling on the circle? Okay, here you have v node in meters per second. Here we have something called w node. Okay, so basically in circular motion, instead of v we say w, and instead of a we say alpha. Okay, very easy. And anytime you want to convert from one of these, this is equal to the radius times this. Okay, but from what I recall, no questions in the quiz involved asking any of these. Okay, the only thing they asked in the quiz, you had to use a normal is equal to v squared over r. This is the only formula they had to use. Okay, but let me see something. D theta over dt. Okay. Okay, in UCM, A tangential equals 0 because A tangential, this is a good question by the way, I think, but you have to know this. Even if it's not a good question, they get this a lot. Because A tangential depends on the change of magnitude of velocity, but velocity in this case, the magnitude of it doesn't change. In UCM, V is equal to RW, and also V is equal to 2 pi R over T. This is an extra formula. Now, this page, the next page, has all the formulas on one page for UCM. Memorize them. Okay? I'll give you the important ones. L is R theta. This is important. This one, this one. Okay. So we did take frequencies 1 over T. Okay, so we did take it, because we had it in the physics periodic. Okay. This was in the physics periodic in the written, so you should know this. W equals 2 pi L equal to 2 pi over T. Wasn't this here 2 pi R over T? Yeah. Okay. This one, I don't really care about this one. Memorize it. So no, memorize it. Last time I told you to do this. Last time I told you something's not important. It came in the written, and most people skipped it because I said it was not important. So don't take my word for it. This one here is important. This is usually equal to 0, and this one is very important. Okay. So memorize these. I don't know what else to tell you. Projectile motion, we're gonna go step by step. Just memorize the formulas. There's a formula sheet that I'll upload. By the time you're seeing this, I'll have it uploaded in the drive, but there's a sheet. Okay, projectile motion, this is how you draw it, right? You should know that it makes an angle theta with the base, with the horizontal. You should know that the only force acting on it is the weight, right? As the particle moves up, it's always weight. So, since the only force acting on it is the weight, just so you understand, you know that force is equal to mass times acceleration from Newton's second law, and you know that the weight is equal to mg. Okay, you're gonna get, if you cancel mass on both sides, that the acceleration here is equal to negative m ay, yeah, because it's going in the opposite direction. The acceleration in projectile motion is equal to negative g. G is gravitational acceleration, always given. Okay, this is the first thing. Okay, this is the first thing. Easy, nice and easy. Okay, the second ones are also very easy. V node y is equal to V node sine theta, and V node x is equal to V node cosine theta. Let's help you understand this. Let's say you start, this is your V, here, right, V node. I want to find the x component of it. This V node is the arrow. I want to find the x component of it, V node x, and I want to find the y component of it, v naught y. How? Remember when you had forces, you just multiply by either sine or cosine of theta. Now we're back to using degrees. Only in UCM you use radians, huh? So let's say if this is like 50, v naught x would be v naught cosine 50, v naught y would be v naught sine 50. Okay, so easy. For for y component we use sine, for x component we use cosine. Okay, then you guys know that v, right, v equal to at plus u, right? In this case, what's the acceleration? Like, let's say we're saying vy. What's the acceleration? I'm starting with the y-axis formulas, with everything that has to do with y. I want to find the final velocity. We know it's at plus u, right? Acceleration of y, which we found it in the first formula, is minus g. Time stays as t, and u is the initial velocity, so v naught y, right? In this case, we want v naught y. What's v naught y? It's v naught sine theta, right? So v naught sine theta. This is how we got this. Okay, very easy. Type next. We know that y or x, the distance traveled. When I say y, you're gonna see y a lot, huh? Is equal to half at squared plus v ut plus x naught, right? That's the original formula. Type. Now we know that the acceleration of y is minus g, right? T squared stays as t. It was ut, right? What's the u initial y velocity? V naught y. What is it equal to? We said it's v naught sine theta. T stays t. And since we're always starting at the origin, y naught and x naught are always 0. Okay, so we just cancel it out. So you're gonna get, this is your fifth formula. Okay, that's your fifth formula. Halla, we're done with the y-axis. Let's go to the x-axis. I drew another graph so you can so it helps you understand. Along the x-axis, we know v naught x is equal to v naught cosine theta, right? The x component is equal to cosine. Type. Sum of all the forces on the x-axis is equal to 0. Okay? That means you cancel the mass, you're gonna get that the acceleration on the x-axis is equal to 0. This is very important. Ax is equal to 0. Meaning that on the x-axis, if acceleration is 0, what does that mean? Vx is constant. But on the y-axis, there's acceleration, right? Ay is equal to negative g, right? Remember we said this is the first thing we said. Okay, so Vx, we know V is equal to at plus u. Since we know mafi acceleration, it's 0, so Vx is equal to u. And u we know is equal to initial velocity, that's what it means, so is equal to v naught x. So doesn't that mean Vx is equal to, what's v naught equal to? V naught x, what is it equal to? The x component of the initial velocity, it's v naught times cosine theta. That's how I just derived it. There you go. So this is the seventh formula. Beside each formula, I'm writing its number. Then we know x is equal to half at squared plus ut plus x naught, right? Type. We know we can cancel this all because on the x-axis we don't have acceleration. We know x naught is always 0. Y naught x naught 0. So you can just say x is equal to vt, right? And what is the x and what is the v on the x-axis? It's v naught x t, right? And what's v naught x? We said the x component of the initial velocity is v naught cosine theta t. Okay. خلاص, now it's a bit easier. At the maximum height, we now want the formula to find the maximum height. Okay. H max we denoted by capital H. At the maximum height, you should know that Vy is equal to 0. What's the expression for Vy? We know that Vy is equal to minus gt plus V naught sine theta. Okay, it was formula number 4, I think. Yeah. Okay, if you don't understand how I got it, go back and watch for like go back, see what I did for formula 4. Okay, we know this is equal to 0 صح. So you're gonna get minus gt plus v node sine theta equals 0. Take minus gt to the other side, you're gonna get v node sine theta equals gt. It becomes positive صح. Okay, can I find the time now? Yes, time would just be equal to v node sine theta over g. That's how I got formula number 9. So this is what we call the time to reach the max height. Okay? Oh, I didn't. What? Why is this opening? Hold up. Yo, wait. Hold up. Okay, this is the time to reach max height. But usually they don't. Yani they ask this, but they also ask what is the total time. The total time airborne. Okay, to help you understand the total time airborne, very easy, guys. Now come on, let's see here. It took you 3 seconds to go up, and you're falling down with the same acceleration you used to go up. So actually the time to go down will be equal also 3 seconds. So in other words, the total time is just 2. This is time to go to the max height, right? The total time t total will just be 2 v node sine theta over g. You just multiply by 2. So here for the maximum height, okay, you just substitute the time we got here. Forget about time total. Just substitute the time to reach maximum height in the equation for y. Remember we said y is minus half gt squared plus v node sine theta t. Just substitute instead of time v node sine theta over g. You're gonna get this squared t squared, right? And then t, you just multiply, and you're gonna end up common denominator. You can just memorize the formula instead of having to do the derivation, but you're gonna get the maximum height is v node squared sine squared theta over 2g. Okay, that's for the maximum height. Now for the range. Okay, or no, then they said total time, you just multiply by 2 like I told you. And then the range is the horizontal distance from O to A. So over here, this is the height, and then from here to here is the range. So the range is the horizontal distance, the height is the vertical distance. Okay, basically it's the horizontal distance from where the projectile motion started to where it ends. From equation 8 and 11, you know that x is equal to v node cosine theta t, and you know that the total time is 2 v node sine theta over t. So I think what do they want us to do? 2 v node sine theta over g time. So they just want you to substitute the time with the total time needed to reach that point, and the total time needed to reach that point is 2 v node sine theta over g, right? X is equal to v node cosine theta. So the horizontal distance at any point is x equals v node cosine theta t. We know the time at the final point is 2 v node sine theta over g. So v node cosine theta times the time 2 v node sine theta over g, you're gonna get 2 v node squared sine theta cosine theta over g, and this sine 2 sine theta cosine theta is in math. It's equal to sine 2 theta. So you're gonna get the final formula, memorize it, v node squared sine 2 theta over g. The maximum range is when theta is equal 45 degrees. That's just a note you can memorize. And then you have an equation that's the time independent equation. The relation between y and x, which is time independent, it's minus g over 2 v node squared cosine squared theta x squared plus tan theta x. This is important. They ask about this. Okay, the most important is the range, the height, and the time independent is very important. Okay, these are discussions. We have horizontal projectiles. Horizontal projectiles means v node is horizontal and theta is equal to 0 degrees. When theta is equal to 0 degrees, you know cosine 0 is equal to 1. So v node x is equal to v node cosine theta, right? And v node y, since it's horizontal, there's no v node y. Okay, because you started like this. It's v node is just like this. Okay, so whenever you have horizontal, theta is equal to 0 degrees. I know sine 0 is 0, that's why v node y is 0. Okay, and here's okay, the smallest speed, by the way, the smallest speed in projectile motion is at the highest point. It was an exercise in the book. Okay, because at the highest point vy is equal to 0. That's the only point in projectile, not in horizontal projectile, in like the actual projectile where it goes like this. Okay, the smallest speed is over here at the highest point. Okay, okay, let's actually solve the quiz now. Okay, the first question, okay, they said a projectile has been launched in vacuum near the surface of Earth. The origin is chosen on the ground with a y-axis pointing upward. Projectile motion. What can be the variation of the y component of the velocity of the projectile with time? Okay, you know that the acceleration of y is equal to minus g, which is minus whatever, let's say 9.8. Okay, meter per second squared. That means your acceleration is negative, so what's gonna happen to velocity? It's gonna start positive and it's gonna begin to decrease. Okay, that's how it looks. Part B, which of the following can be the variation of the x component of the velocity with respect to time? We know that the velocity Vx is equal to V node cosine theta, right? And it stays constant. Vx is constant in projectile motion, right? So it stays positive. It can't be negative, huh? Which of the following can the variation of the acceleration of the projectile with time? The acceleration ay is always equal to minus g, right? So it's always equal to negative 9.8 or negative 10, whatever it's given. So it's always gonna be this. It's gonna stay at negative 10 or negative 9.8. Okay, question 2. Okay, you have a stone is thrown from the top of a cliff with a speed of 15 meters per second at an angle of 30. So they gave you v node is equal to 15 meters per second. Theta is equal to 30 degrees. Okay, the total time, t total, is equal to 5, and they gave you g is 9.8. They gave you this. What is the initial vertical component of the stone's velocity? How do you find v node y? It's equal to the v node sine theta, right? You want the y component, you multiply by sine. So it's going to be equal to 15 sine 30, which is 7.5. How long does it take the stone to reach point y? So we want the time. Okay, some people will be like, how are you gonna do it? No, how are you gonna do it? No way. Let's forget about this bottom part here, and let's look here. Y is at the same height as our initial point, right? So how I solved it is I split it up into two projectile motions. There's one big one, and you can split it up into this small one over here. Okay, how I looked at it is over here. I wanted to find the total time between here and here. And if you look at this as one projectile motion, it went up, it reached the maximum height, it went back down to the original height. Okay, so can we find the total time here? We know time total is equal to 2 v node sine theta over g. Okay, let's see. V node sine theta is Vy, which is 7.5, and g is 9.8. You're gonna get approximately 1.5. It's 2 times 7.5 divided by 9.8, 1.53. Okay, so approximately 1.5 seconds. Then they say, what is the height of the cliff edge? For the height of the cliff edge, you want to find the distance here, y, given that the total time is 5 seconds. So very, very, very easy. You should know that y is equal to minus half gt squared plus v node sine theta t. We have time, we have v node sine theta, we have everything. We can just solve it. So y is equal to minus half g, which is 9.8, t squared, which is 5 squared. We're talking about the total time for the whole motion, right? So now we look at the whole projectile, plus v node sine theta, which is 7.5. We found it here. Or you can just write 15 sine 30. It doesn't matter. And that t is 5. You're gonna get negative 0.5 times 9.8 times 25, because 5 squared, plus 7.5, 5. You get minus 85. Why is it? So of course you're gonna get y is equal minus 85 meters, because you're going downwards, right? So the height of the cliff is how much? 85 meters. Okay, but if you had a written part, you'd have to say h is equal to negative y, because you're going downwards. Okay, but that doesn't matter. That doesn't matter right now. All you should know, 85 meters. Just make your answer positive. Question 3. Okay, this is a nice and easy question. The diagram below shows the path ABC followed by a girl walking her dog for 0.6 hours. The average speed of the girl is what, and the average velocity? Let's see. She's using the path ABC. Average speed is L over T, right? Delta L over delta T. And the path here, it's going from A to B to C, right? So 1 plus 2.8 divided by the time, 0.6. This is a very easy question. So 3.8 divided by 0.6, I'm pretty sure you get 6.3. 3.8, you get 6.3. And of course average speed isn't a vector, it's a scalar, so it has no direction. Okay, average velocity is delta r over delta t. صح. Okay, what's the displacement? It's 3 over the time 0.6, and you're gonna get 5. And akid, what's the direction of it's going upward? They gave you that upward is north, so it's akid directed due north. Yes, this question is a bit easy. 4, I think, is a vector question. Yeah, okay, this is very easy. Okay, the initial distance. Okay, you have a particle moves from point A to point B in 4 seconds. The initial distance of the particle from the origin is how much? Okay, the initial distance from the origin, you started at 3 meters, so it was 2I plus 3j. Whenever you're asked to find the distance, that means they're asking you to find the magnitude. How do you find the magnitude? Radical 2 squared plus 3 squared, you're gonna get radical 13, which is about 3.6. Okay, the average velocity of the particle to 1 decimal place. How do you find average velocity? When you have two vectors, it's equal to delta r, delta r over delta t, صح? Okay, the change in r. You have the x component, y component. Let's find vx and let's find vy. Okay, vx is going to be 4 minus 2 over the time, which is 4 seconds. Vy is 11 minus 3 over also 4 seconds. So here you're going to get 0.5 meter per second I, and here you're going to get 2 meter per second j. Okay, then what's the average speed? You know that average speed is equal to the magnitude of the velocity, so just find the magnitude of this. So it's going to be equal to radical 0.5 squared plus 2 squared, which is around 2.1. Question 5. Okay, they gave you r is equal, hold up. Okay, here they gave you the position r is equal to 5. Like for the I component, please don't it might be a bit confusing the way they write it, but like it ain't that bad, wallah. Okay, so 5 plus 4t I, and then you have minus 2t squared for j. Okay, the displacement of the particle in the first second, yani between 0 and 1 second, right? So you're gonna do the displacement, so r of 1 minus r of 0. So let's find r of 1. R of 1 is gonna be equal to 5 for the I component. 5 plus 4t, so 4 times 1 I, plus for the j component it's minus 2 t squared, so 1 squared j. So this is going to be equal to 9i minus 2j. This is r1. r0, substitute 0, is going to be 5 plus 0, so 5 plus 0 I plus 0j, because 0 as t, you're going to get 0 squared times minus 2 is 0. So 0g. So you're gonna get 5i plus 0g. We're gonna do r1 minus r0. So this minus this. So you're gonna get 4i minus 2g. Okay. The magnitude of the average velocity in the first second of motion. How do you find the magnitude? Just do 4 squared plus minus 2 squared. Let me do this because I got the answer wrong when I was solving. 4 squared plus 2 squared, 4.5. Okay, yeah. How do the magnitudes of average velocity v and average speed s in the first second of motion compare? Okay, obviously speed is not equal to like the displacement. It's equal to the distance divided by the time. So akid, in this case, for velocity we had to subtract to find the displacement, right? But for speed you don't. It's just distance divided by time. So of course the speed will be greater than the velocity. And whenever speed is greater than the velocity, it means the trajectory of the particle is curved. Okay, just memorize this. Know it, okay? If speed is greater than velocity, then the trajectory of the particle is curved. Okay, you have here now velocity is given minus 5t for I, and the j component is 1 minus 10t plus 2t squared. Forget about the units are just there to confuse you really. Okay, initially the particle is at the origin. Okay, the unit vectors I and j point toward east and north, whatever. Select the diagram correctly represents the direction of the initial velocity, so v0, v0, right? So at time equals 0, how much is the initial velocity? When t equals 0, we don't have an I component, right? Because when t equals 0, minus 5 times 0 is 0. So it cancels out the I component. And then it cancels this out, right? And it cancels this out. So you're just left with 1j. 0i plus 1j. So will I be going right or left? No. We're only going to be going up. So that's why this is how it looks. The expression for the acceleration is given by what? We know acceleration is equal to dv over dt. Okay, so actually we're going to derive the I component and then the j component. So let's see. ax is equal to dvx over dt. Let's see. Minus 5t, derive it, you're going to get 1 times minus 5, it becomes minus 5. Reduce the exponent of t by 1, you're not going to have any t anymore, right? So ax is minus 5i. Okay, then ay is going to be dvy with respect to dt, صح? You derive dvy. 1, you derive it, you get 0. T times 1 times minus 10, it's power. 1 times minus 10 is minus 10. Reduce the exponent of t by 1, خلاص you won't have it anymore. Then you're done with here. Then t squared, 2 times 2 is 4. Reduce the exponent by 1, it becomes t. So this is how it's going to be. So minus 5i, then you're going to have minus 10 plus 4tj. The magnitude of the average acceleration, how much is it? How do you find the magnitude? To find the magnitude in the first second of the motion, you just in the first second of motion, so you can substitute t equals 1, find the vector I. So at t equals 1, a is going to be e minus 5i plus minus 10 plus 4t. What's t? 1, right? So minus 5i, this is j over here, plus minus 10 plus 4, it should be minus 6j, صح? Okay, find the magnitude of this, you should get 9.4. So radical 5 squared plus 6 squared 7. Oh, what did I do wrong? Okay, my fault, never mind. This is the, sorry, I didn't read the question properly. This is the expression for instantaneous acceleration. Here they want average acceleration. Remember, when they say average velocity, you won't use v equals, you can use x equals. Okay, like what I'm trying to say is, for average velocity, remember when I used to tell you, if they ever ask for average velocity, you do x final minus x initial over time. But here they want average acceleration, you're gonna do what? When you see average, you have to use the one before it. So like, if you have x v a, if they ask for average velocity, you use the x. If you ask for average acceleration, you use the v. Okay, let's see here. In the first second of its motion, so between 0 and 1 second. Okay, so I want v1 minus v0 divided by that time. Let's find v1. v1 is equal to minus 5 times 1 I plus 1 plus minus 10 times 1, right? Plus 2 times 1 squared j. You're gonna get minus 5i minus 10 minus 9 plus 2 minus 7 j. So this is v1, right? How about v0? v0, you're gonna get if you substitute t equals 0 here, you're gonna get 0i, and here you're gonna get this cancels, you're gonna get 1, right? Plus 1 j. صح. Yeah, subtract minus 5 v1 minus v0, minus 5 minus 0 is minus 5i, minus 7 minus 1 is minus 8j, divided by the time. The time is first second of motion, so 1, so it's gonna stay minus 5i minus 8j. Well, let's find the magnitude, because they asked magnitude. You're gonna do radical 5 squared plus 8 squared 9.4. Okay, question 7. Again, they gave you a vector, position vector. The magnitude of displacement in the first 10 seconds is what? Displacement, again, first 10 seconds, so between 0 and 10. Okay, so we're going to do r of 10 minus r of 0. Let's see. R of 10, we're going to substitute. Minus 10 times 10 plus 2 times 10 squared I, right? Plus the j component 1 plus minus 6 times 10 j. You're gonna get minus 100 plus 200, you're gonna get 100i plus minus 59 j. Yeah, and then for r0, this is r10, right? For r0, you substitute t equals 0, you're gonna get 0 here, 0 here, 0 here, you're only gonna have 1j. So r0 is 0i, sorry, 0i plus 1j. We want r10 minus r1, right? Between 0 and 10. So subtract 100 minus 0, 100i. Minus 59 minus 1 is minus 60j. Find the magnitude of this, because he said magnitude. So radical 100 squared plus 60. 116.6 to the nearest integer is 117, صح? When is the velocity of the particle strictly vertical? When we say strictly vertical, يعني Vx is equal to 0. Vx is equal to 0 when... If you want to equate Vx to 0, we need to find first what's Vx. Vx is equal to the d derivative of r, the x component, over time, صح? So we have to derive this here. 1 times minus 10 is minus 10, and then reduce the exponent by 1, you're done. T squared 2 times 2 is 4. Reduce it, becomes 4t, right? We know this is going to be equal to 0 when it's vertical, right? There's no x, right? So it's equal to 0. So you're going to get t equals 2.5 seconds. When can the velocity of the particle be considered horizontal? Horizontal, يعني Vy is equal to 0. Let's find what's Vy. Vy is equal to derivative of r, y component, over dt, صح? Let's see. 1 we derive, you get 0. 1 times minus 6 is minus 6. Reduce it by 1, you're done. So Vy is always equal to minus 6. Can you equate minus 6 to 0? No, mathematically incorrect, so it will never be only horizontal. Select the diagram that correctly represents the direction of the initial acceleration of the particle. The initial acceleration, يعني a0, a node is equal to dv over dt. Like acceleration equal to derivative velocity with respect to time. نحن we got from part B, I shouldn't have erased it, but we got that Vx is equal to minus 10 plus 40. So Vx is equal to minus 10 plus 40i. And Vy we just got is minus 6j. Can we derive this again? Yes, it's going to be equal to, derive this one, you're going to get this 10 cancels. 1 times 4 is 4. It's 4i. And then what's the derivative of minus 6? It's 0, because it's a constant term. So your acceleration is equal to 4i plus 0j. So since it doesn't have a vertical component, only a horizontal component, what's it going to be like? It's going to be like this. Okay. Question 8. A particle is moving along a curved trajectory shown below as a dashed line. It moves from A to B in 4 seconds. The velocity vectors are shown below, and each square is 1 meter per second. Select the diagram that represents the direction of the average acceleration as it moves from A to B. So to find average acceleration, it's velocity final minus velocity initial divided by time. What some people here, they get confused, like, well, what do we have here? These are the velocity vectors. What's the vector of A? It's 1i plus, how much does it go up? 1, 2, 3, 3j. So A. How about B? 1, 2, 3, 4, 4i plus 1j. Okay, we're gonna subtract final minus initial. 4 minus 1 is 3i. 1 minus 3 is minus 2j. So which one is it? Is it this one? Obviously no. Is it this one? No, because this is negative I. This is also negative I. This is positive I, negative j. And we have that, right? So it's gonna be this one. The magnitude of the average acceleration is how much? We got this is average acceleration. Since the time... Oh, hold up, wait. Yeah, we're gonna divide by 4, right? Since the time is 4 seconds. So we're gonna divide all of this by 4. So 3 over 4 I minus 2 over 4 j. That's the average acceleration, right? Because it has to be velocity final minus velocity initial over time. You didn't really need to divide by 4 because also it won't change the sign. Here, what matters is just the sign. It's going right, then down. Okay. So you get this. You want to find the magnitude. How do you find it? 3 over 4. Sorry. 3 over 4 is just 0.75 squared. 2 over 4 is 0.5 squared. You get 0.9. Very nice, very easy, very straightforward. Here, they gave us the velocity, okay, along a circle, so it's UCM, right? They gave us the velocity is 3 sine 2 rad, okay. They trick you with this, but it's 3 sine 2 rad. You can just put this in your calculator for the I component, and then it's 3 cosine 2 rad for the j. Put this in your calculator, okay. Well, you know, before we do that, let's see what they're trying to ask, okay. They want the normal component and they want the tangential component. Without even solving, a tangential in UCM is always equal to 0, okay. The normal component a normal is v squared divided by r, okay. V squared over the radius. The radius has to be in meters. 25 centimeters, 0.25. Okay. So the v squared, we need to find velocity. Then you need to find the magnitude, right? And I found the I and j. I need to find the magnitude. So actually, let me find what 3 sine 2 is and what 3 cosine 2 is. So it's a bit easier. You need to shift, go to radians. And please don't forget to convert back to degrees. Change your calculator back. Don't make the mistake of solving in radians throughout the whole exam, because you're going to have to use degrees for projectile motion. Okay. 3 sine 2 rad. You got this? Let's just round it up to 2.7. or you know what, before, let's just put it directly. Find the magnitude. 3 sine 2 rad squared, 3 sine 2 squared plus 3 cosine 2 rad squared, right? The rad just means change your calculator radius. You're gonna get 3. Okay, so V, the magnitude of V is equal to 3. And I want V squared over 0.2 over R. So it's gonna be 3 squared over 0.25, 36. Okay. Question 10. Okay. The magnitude of a particle, the magnitude of speed is V is 2 meters per second plus 3t. At t equals 2 seconds, the particle is moving along a curve of radius 5 meters. Radius يعني UCM. At t equals 2 seconds, the normal component, the tangential component, the acceleration. Before moving on, somebody might ask me, why isn't the tangential component 0 here? Okay, because they didn't say it's moving uniformly. Like in the last one, I think they said it's moving uniformly. Yeah, here they said it's along the circle. Okay, here they didn't really say along the circle, they said it's a curve, but the curve has a radius 5. Okay, if they don't say uniformly or don't say along the circle, then it's not UCM. Okay, so let me erase this, but it will still follow the same formula. The normal component of the particle's acceleration to 1 decimal place, you know an is equal to v squared over r. At t equals 2 seconds, let's find the velocity. v2 is equal to 2 plus 3 times 2. So it's going to be 6, 8, 8. So it's going to be 8 squared over the radius 5. So is this correct? 12.8? 64 divided by 5. Okay, yeah, 12.8. Okay, the tangential component of the particle's acceleration. If they don't say it's UCM, or if it's not along a circle or uniformly, then you have to use the formula that A tangential is just the derivative of velocity divided by time. Very easy formula, guys. Derive velocity, you get acceleration. What's the derivative here? Derivative of 2 is 0. 3t gets you 3. Okay, 1 times 3 is 3. Reduce exponent by 1 becomes 3. So 3 meter per second squared. Okay, the acceleration to the nearest integer is, yeah, so whenever you have tangential and normal acceleration, you are asked to find the actual acceleration. It's just the magnitude of it. Okay, so you go back here, find the magnitude. Radical 12.8 squared plus radical plus 3 squared 13.1 to the nearest integer 13. Okay. Question 11. A boy is winding a rope of length 30 with a small rock attached to it. So you have this rock. Okay. The rock makes 2.5 full turns in 3 seconds in a uniform manner. The normal acceleration of the rock and the tangential acceleration. Here, tangential acceleration is 0 because they gave you it's a circle. Okay. Easy. The normal acceleration of the rock again is going to be v squared over r. So whenever they tell you anything about full turns, you're gonna use the equation v equals 2 pi r over how long a full turn is. To understand this, 2 pi r is the circumference. Okay, you know, velocity is equal to distance divided by time. Circumference is the distance to make one full turn, and obviously the time, the capital T, is the time to make one full turn. So time for one turn. Okay, it makes sense, you know what I mean? So let's see here, v is equal to 2 times pi times the radius. It's 30 centimeter, which is 0.3 meter, right? So 0.3 over the time. They said you got 2.5 full turns in 3 seconds. Okay, so how much is one full turn? How much time is that? 2.5 turns in 3 seconds. How much is one turn? It's, I don't know, 3 divided by 2.5. So you're gonna get 3 divided by 2.5 as the time for one turn, right? You just do 3 divided by 2.5. Okay, put this in a calculator. Okay, 2 pi times 0.3 over 3 divided by 2.5, you get this. Okay, so this is v. We want v squared over r, so half pi squared over the radius 0.3. So square this and divide by 0.3, you get 8.2. Okay, so that's how you got this, and we said a tangential is obviously 0 because it's along a circle. Okay, very, very easy. Question 12. A ball is projected. Okay, finally some projectile motion. It's projected horizontally. Horizontally is very important. Horizontally means theta is equal to 0 degrees. At 40 meters per second, v naught is equal to 40. 6 meters above the ground. So y... Okay, I don't know if that's important. We will get to that. Okay. Neglect air resistance and use g equals 10. The time the ball remains airborne is to one decimal place how much? Okay. Time is equal to v naught sine theta over g. But someone's gonna come and tell me. He's gonna tell me, طب وليد, your theta is 0, how are you gonna use this? You can't. Okay, so let's not use this. We know it's 6 meters above the ground, so we have y. Okay, always where you start is 0. So let's think about it like this. Okay, since it's horizontally, it's gonna start falling, right? And how much is this fall? 6 meters. So y final, if you take the point, we always take the initial point as 0, y final is minus 6, right? So y final is minus 6. What's the equation for y? It's minus half gt squared plus v naught sine theta t, right? Let's see. Our final y is minus 6 equals minus half g, which is 10, t squared. V naught sine theta is 0 because sine 0 is 0, because we said theta is 0 since horizontal. So can we solve this? Yes, of course we can. Minus half times 10 is minus 5t squared plus 6 equals 0. You're gonna get how much is this? 6. You're gonna get negative 6 divided by negative 5, which is just 1.2 square root, which is 1.1. You guys know how to solve this, huh? So you get 1.1 seconds. The horizontal distance the ball travels before it hits the ground is what? Horizontal distance is range, right? Or x value. Okay, again, the range is equal to v naught squared sine, I think it was 2 theta over g. Let me just make sure of this. It was but in this case theta is equal to 0, so can you use this one? No. What else do we know? Range means you're trying to find x. X is equal to v naught cosine theta t. Okay, this is a nice formula and it will work. You can say to body theta is 0. Ma habibi, cosine theta cosine 0 is 1, but sine 0 is 0. Okay, so it will work to use cosine but not sine. Okay, v naught is 40, it's given in the question up here. Cosine 0 times 1.1, and you get around 44 meters. Okay, select the diagram that describes the variation of speed with time. Akid, انت you're dropping it horizontally, it will always look like this. Okay, since انت you're dropping it, it starts here, then it starts accelerating, right? And here it should drop down to 0, but like they don't have to write it. I don't know, but usually, and I prefer if you write it here, because to show that it hit the floor, it stopped, right? So it's gonna be like this. Why is it curved? Because it's accelerating, guys. Okay, this is wrong. No, why would it be? Okay, this works. Yeah, just memorize it like this, guys. Okay, this is the famous canon question in projectile motion. it's in the book, it's in every past paper. They always like to get this canon question or some sort of shooting something, like some question like this. These questions are very easy because like everything's given to you. Okay, a cannon is projected at 200 meter per second, we know it. Angle of 10 degrees, theta. Neglect air resistance and use G equals 10 meters. So we have G. The greatest height attained by the cannonball, very easy. Greatest height is V naught squared sine squared theta over 2G, right? V naught squared 200 squared sine theta is 10, so sine 10 squared. For people who are confused about how to do this, you just put sine normally and then square it, okay? Over 2 times 10. I think my calculator is still on radians. Yeah, let me change it to degrees. Please make sure you change it to degrees. 200 squared sine 10 squared over 20. 60. Okay, greatest height is 60. A cannon hits a target 12 meters above the ground. Above the ground, yani y is equal to 12. The time it takes to strike the target after launch to one decimal place is how many seconds? We know y is equal to 12. We want to find the time. What is y equal to? Minus half gt squared plus v naught sine theta t. So 12 equals minus half 10t squared plus v naught sine theta. V naught sine theta is 200 sine 10. The t, which is, we don't know, we're trying to find, right? Let's put this all as a quadratic. Move everything to one side. You're gonna get minus 5 because minus half times 10. Then 200 sine 10 for your t. And then take 12 to the other side, becomes minus 12, صح? You get 6.6 seconds and 0.36 seconds. أكيد it won't be 0.36 because why won't it be 0.36? Yeah, so why it isn't 0.36 is because I think they mean like over here 12 meters at the end. So the second time it hits. They should be more precise. No, I don't want this. I mean 6.6. So it's, oh no, take me back. Question 13, صح? Okay, it should be 6.6 seconds. Yeah, 6.6. Part B, the horizontal distance between the target and the cannon. Okay, this is very easy. To find the horizontal distance, we're trying to find x. X is equal to v naught cosine theta t. Now that we have the t, 6.6, we can find x. So x is equal to v naught 200 cosine theta, which is 10, times the t, 6 point, let's just say 6. And you should get it 200 cosine 10 times 6.6. Ooh, why is this? How much? Yeah, 1.3. Yeah, two possible answers. I think it's for any other, like some people they might use the non-rounded value. 1.3, like they want it in kilos, so you divide by 1000. Yeah, I got 1.3, and that is the correct answer. Okay. Question 14. Okay, another question very similar. I'm telling you, these questions they like to get them. A ball is projected at 25 meters per second. We know it with an angle of elevation 37 theta. Okay, and they gave you g. What's the speed of the ball at the topmost point of its trajectory? At the topmost point, Vy is equal to 0. You only have Vx. Okay? At the top. What is Vx equal to? We always know Vx is equal to V naught cosine theta. Because Vx is constant, it's always equal to the cosine. Okay? So it's going to be 25 cosine 37. Right? That's what Vx is. Okay, that's why at the highest point there's no Vy. At the highest point, V, like look at the top, V is only equal to Vx. Okay, 25 cosine 37, 19.9. So yeah, I need 20. The greatest speed attained by the ball when it's airborne is how much? The greatest speed always memorizes the top speed, the highest speed is at the start or end. Let me explain this to you. Until you start here. You start going up, you start decelerating because of gravity, right? Then you reach here. Then you're going to start falling down and you're going to reach the same speed you started with. So here it's decreasing, then here it increases until you reach the same speed you started with. So at the end of the day, the 25 you started with decreased maybe up until 20 here, and then you go back down, it starts increasing again. Okay, so always the top speed is the final speed you have or the initial speed you have. Okay, and we started with 25, so it's just 25, very easy. The trajectory of the ball with no time. The equation is I think it was minus g over v naught squared cosine squared theta x squared plus tan theta x. If I'm not wrong, let me just make sure. 2 v naught squared cosine squared theta. Okay, yeah, it's 2 here. 2 v naught squared cosine squared theta. So let's substitute. Minus g is 10 over 2 v naught squared, so 25 squared cosine squared 37 cosine squared 37 x squared by the tan 37 x. Let's see what we get. You have minus 10 over 2 times 25 squared cosine 37 squared minus 0.0125, right? And then tan 37 0.75. Okay, easy. Okay, the diagram below shows the trajectory of an ideal projectile near the surface of the earth. Use g equals 9.8. The straight line shows the tangent to the trajectory at the origin. Okay, they're asking to find the angle above the horizontal at which the projectile was launched. The angle, always when you want the angle, use shift tan. Like if you have a graph, shift tan y over x. Very, very easy. Here, your y is, it went up by 20. 20 over your x, it went by 0.5. What did how 0.5? Because look, 1, like you have 2, and there's 1, 2, 3, 4 squares. 2 divided by 4 is 0.5. So each square is 0.5. You're gonna get 40. So shift tan of 40. And you should get 88.6, right? 40, 88.6. Here, to find the initial speed, you can do two ways, okay? From the graph, you have to use the graph. You have that the height is how much? 80. And you also have that the range is 8. You can use whatever. I'm going to use height because I like height. Height is easier. The equation for height is v naught squared sine sine squared theta over 2g. I think. What was this? Yeah. And in this case, this is all equal to how much? 80, right? Let's start substituting. V naught squared, we don't know it, we're trying to find it. Sine theta squared, sine theta is 88.6, right? So 88.6 squared over 2g, so 2 times 9.8. Let's put this, let's just solve this. We are going to multiply 80 by 2 times 9.8. You get 1568. Then you're going to divide by sine 88.6 squared, right? Sine 88.6 squared, something like this. And then you're going to find the square root, right? 39.6, so about 40. This is just solving equation. Everybody should know how to solve this. Multiply, divide by this, take the square root. Okay. The time the projectile remains airborne. Okay. The total time is always 2 times the time to go up, which is v node sine theta over g. So it has its own equation, time total. It's 2v node sine theta over g. So you're gonna get 2 times 40 sine 88.6 over, what was 9.8? 8.16. They rounded it to 8 seconds. Question 16. A shell is dropped from a bomber moving horizontally. Please keyword horizontally. Theta equals 0 degrees. At 100, so V node is 100. And the altitude is 405 meters per meter. So Y at the start, Y final will be how much? If you're dropping it, we always start at 0. If you're dropping it 405 meters, Y final is minus 405. Okay, this is the way I do it. Some other teachers, they solve differently. This is the way I solve. Okay, take G equals 10 and neglect air resistance. Choose the correct answer. Okay, okay. The horizontal speed of the shell 2 seconds after it has been dropped. Okay, you must know horizontal speed Vx is always constant, right? So Vx is equal to V node cosine theta, right? So in this case it's gonna be 100 cosine 0, which is 100. The vertical speed of the shell 2 seconds after it has been dropped is how much? The vertical speed Vy, at the instant that it was dropped, it was 0. Well, we don't care about that. We're saying now 2 seconds after it has been dropped. You should know Vy is minus gt plus V node sine theta, right? Minus gt minus 10 times 2 plus V node sine theta, which is 100 sine 0, which is just 0. Okay, and so you get Vy is minus 20 meter per second. The time it takes for the shell to reach the ground. Total time is equal to 2 V node sine theta over g. I don't think you can use this. Yeah, I don't think you can use this. Let me try. I just want to see if it's... Yeah, you can't use this because theta is equal to 0. So always for horizontal, you want to find time, you're not allowed to use this equation because theta is 0, so sine theta is 0. What do we know? They gave us that it's 405 meters. We know that the final y is minus 405, right? So minus 405 equals to minus half. What's the equation? Let me write the equation on the side so you don't get lost. Minus half gt squared plus v node sine theta t, right? So minus half gt squared. Let's substitute. I want to write g. G is 10 t squared plus v node sine theta. V node is 100 sine theta, which is 0 times t. Okay, we know this is cancels, because sine 0 is 0. So you're gonna get minus 5t squared equals minus 405, and then you should be able to solve this. 405 divided by 5, because they're both negative, so it doesn't matter. Then square root of 81, again 9 seconds. Some people might ask me, Tawali, they said it's 405 above the ground. Why did you put y final as minus 405? Again, I'll explain it again. Think of it like this. It's a bomber. You guys know the planes, the bomber planes. They fly and then they drop the ball horizontally. So it goes like this. So this here is 0. And since it's 405 above the ground, it's going to be minus 405. always your starting point is 0. Even if you're 405 above the ground, it would be 0. طب حتى if this is 0, that means here's minus 4 or 5. Okay, very very good, very easy. Until now يعني it's just formulas, application of formulas, guys. A projectile is launched at an angle, and they said tan of that angle is 5/8. So you can easily find what the angle is. Just do shift tan at a speed of 17 meters per second, so v naught, and they give you g, and we have, let's find theta. Okay, so they want us to find the range of the projectile. The range r is equal to v naught squared sine 2 theta over g. Wait, is it, or isn't it, it's sine 2 theta, صح? Range is sine, yeah, okay. طيب, and this is, we need theta first. Okay, before doing anything, I'm going to tell you theta is equal to shift tan 5/8, صح? We want to find the angle, or alpha, whatever you want to call it. Shift tan 5/8, 32, let's just say 32 degrees. Type, so v naught squared sine 2 theta, so v naught squared 17 squared sine 2 times 32, صح? Over g, which is 10, should get, let's see, 17 squared sine 64 over 10. 25.9 to the nearest integer, it's 26. Okay. The maximum height of the projectile. Maximum height, h, is equal to v naught squared sine squared theta over 2g. This question, I'm telling you from now, they will bring it. Okay, if not like this, they will give you a question where they want range and maximum height only. Yani. V naught squared 17 squared sine 32 squared over 2 times 10. 17 squared sine 32 squared over 20. You get to the nearest integer 4 meters. Last question. Honestly, I was very confused about this one, but then I got it. They said a body of mass 5 kilos is thrown upwards. Remember when we said thrown horizontally, theta was 0. Now when it's thrown upwards, theta is 90 degrees. It's thrown vertically upwards. Okay. With an initial speed of 20 meters per second, v naught, take g equals 9.8. For this one, only for the case of being thrown upwards, you can use the equations for free fall. And the equations for free fall were just the UARM formulas. I'll show you the way I do it, and then we'll see. The highest point that the body reaches is how much? The highest point, h, is equal to v naught squared sine squared theta over 2g. V naught squared, so it's going to be 20 squared sine 90 squared over g 9.8. Let's see, do we get the correct answer? 20 squared sine 90 squared over 9.8. Okay, hold up. Is it not? It's 2g. Why did I put 9.8 on? 9 over. So let me divide by 2. Yeah, 20.4. 20.4. If you want to be fancy, you can use v squared minus u squared equals 2ax. Some people will like the, in this case y. No? You can be fancy because final velocity is 0. You're going to get minus 20 squared equals 2 times 9.8 times y, and you're going to get the same thing, huh? You're going to get negative, sorry, so 9.8. You're going to get same answer, 20.4. But I don't want to confuse you. Let's stay, we're doing projectile motion, let's stay on projectile motion. The time to reach this altitude. The time, total time is 2 v naught sine theta over g. But that's total time, and I want normal time. That's why I wrote two separate equations. The normal time to reach the height is v naught sine theta over g, right? So 20 sine 90 over 9.8, just 20 divided by 9.8, which is 2 seconds. Okay. The time it takes the body to reach half the maximum height for the first time. Okay, so you just find half the maximum height. Half of the maximum height, 20.4, is 10.2. We want to know the time. So this is the y, right? This is the y. Okay, what is y equal to? Minus half gt squared plus v naught sine theta t. We know that the final y is 10.2 equal minus half, g is 9.8, t squared plus v naught sine theta, so 20 sine 90 t. Okay, you're gonna get minus 4.9 t squared plus 20 sine 90 is 20. I'm just gonna give it to you from now. Minus 10.2 equals 0. Move it all to one side, because we're trying to solve a quadratic. Okay, put it in your calculate equation mode. Minus 4.9, 20 minus 10.2. For the first time, so they want the smaller value, right? They're saying for the first time. So we take not the bigger value, the smaller value. 0.6 seconds, right? Or they didn't tell you to round it to one decimal place. Okay. هيك نكون we're done. Please make sure to solve the grid questions that are here, these three, in case you don't know them يعني. Okay. Other than that, thank you so much for watching. Oof, good luck.